This is the last section of Unit 1, looking at measures of relative standing and box plots. So just a quick overview of what we've done in this chapter. Measures of center, we were trying to find the middle of the data. Things like the mean, the median, which again either is x tilde or, which we'll learn in this section, Q2, those both are the median. So ways of measuring where's the middle of the data. Section 3.3, we talked a lot about variation, and in particular, we talked about the standard deviation, which is a measure of how spread out the data is. Does it stay close to the middle, to the mean, or does it spread out a bunch? For section 3.4, we're talking about, okay, well, how far does an individual value vary from the middle? So if we've got our mean here, how far away is this data value that we have over here? Or how far away is this data value that we have over here? So that's kind of the general idea of this section. So the first thing we'll talk about is the z-score. Z-scores will be important in this class for about the next 10 weeks or so. So we need to get it hammered out on what they are. It's the number of standard deviations that a value is above or below the mean. Just so you know, we'll be rounding to 2 decimals on z-scores because we will be using a table for z-scores, and that table has them all rounded to 2. So they go further than that, but we'll stick to 2. So just a quick example before we get into the actual problems on here. Let's say that the mean, we'll make something easy. We'll say the mean of some data set is 10. And we'll say that the standard deviation is 2. So if I had a data value sitting at, if I had some individual value that was at, let's say 4. The question is, what would that z-score for the 4 be? Well, if the middle is 10 and every 2 hops is a z-score, or excuse me, is a standard deviation, then 2, 4, 6, I would hop down from 10, hop down to 8, hop down to 6, hop down to 4. I just hopped 3 times, and I hopped 3 times lower. So my z-score would be -3. If I had a data value of, say, let's try something a little crazier. What if I went with 13? So if my data value was 13, and every 2 is a standard deviation, okay, so if I start at 10, I'd hop a standard deviation to get to 12, then 13 would be in the middle. That'd be another half of a hop. So that is 1.5 hops, 0.5. So that means the z-score that goes with 13 would be 1.5. Now, not all data values are going to land at these nice increments, so we need to have a formula for it. Formula for the z-score, which we will use over and over and over again, is x minus the mean divided by the standard deviation. So basically, we're figuring out how far away the data value is from the mean, but then we're measuring that in terms of standard deviations. And just what we talked about with the range rule of thumb previously, our ordinary values, notice these are z-scores down here on the bottom, our ordinary values are within 2 standard deviations, so a z-score of -2 to +2. Anything outside of that we usually consider unusual. And if we go back to the stuff we discussed with the normal curve, remember this would represent about 95% of the data in here. Most of it's in that ordinary values. So for number 6, the mean adult pulse rate is 67.3 beats per minute, and we have a standard deviation of 10.3 beats per minute. So what we're going to do on this one is we're going to calculate the z-score for this. So it's x. So if a man's pulse rate is 48, that's going to be my x value. I'm going to subtract off the mean, 67.3. And I'm going to divide by the standard deviation, 10.3. And again, this is to calculate my z-score. And again, that score is for the specific value, 48. So if I run those numbers, and again, I'll round to 2 decimals, that would be negative 1.87. So this is basically saying that if I think of this like on a number line here, that the z-score that associates with 48 would land right about here, negative 1.87. Is that unusual? No. That's still in the usual range, the ordinary values. For letter B, what would be the upper limit for a normal pulse rate? Well, probably the easiest way to do this, and there's a few options here, is to say, all right, to get the upper limit is right here. Well, I just ask myself, okay, that's a standard deviation, and that's a standard deviation. So the middle would be the mean, which is 67.3. I'm going to add on a standard deviation and add on another one. So really, it's exactly what we did in the last section, 67.3 plus 2 standard deviations. So the upper limit, if I calculate that, would be 87.9. So I'd have a measure that if I measured some adult male and their heart rate was higher than 87.9, I could say, okay, this is in the unusual range. We got to check this out. Another way to measure relative standing is through percentiles. Now, percentiles don't have anything to do with the mean. They have to do with ordering stuff from least to greatest. So these are a measure of location. Now, be careful, percentiles are not the same thing as a percentage. So if I say you're in the 90th percentile, that does not mean you got a 90%. It just means you did better than 90% of students. You probably saw percentiles when you looked at your ACT or SAT scores. A higher percentile means you did better than that percentage of people. So the way we calculate a percentile is we count how many values are less than it. We don't really care what the value itself is. We care about how many are less than it. And then we divide by the total number of values, and to turn it into a percentage, we multiply by 100. So, for example, 7, we have already ordered, which is good. The amount of chocolate chips in 40 Chips Ahoy cookies. So find the percentile for a cookie with 25 chips. Okay, so I go to 25 and I go to the first time I see 25. And I count how many values are less than that. Again, I don't care what the values actually are, I just count how many are less than that. So I'm basically counting all of those. So if you count how many those are, that is, I believe, 22. Let's change pen colors here, maybe not yellow. 22 divided by the total, which is 40. Oops, don't know how that happened. And then we'll times that by 100 to turn it into a percentage. And we end up with 55. So the way I want to write this is I say that P55, that's percentile 55, is the number 25. So again, all this means is that 55% of the data is below that number. Now I know this is on its side. I couldn't fit this little flow chart in there vertically, so you'll have to turn your computer, or if you printed this out, you'll be fine. This is going to be converting, if I tell you the percentile, to figure out the data value. So this is going the other way, and we'll go through this on the next page here. So off of percentiles comes the idea of a quartile, which you may have heard of. Obviously, the root here is quart, quarters. We divide the data into 4 equal parts, 4 quarters. The nice thing about quartiles is they're just special percentiles. So quartile 1 is really just percentile 25. Quartile 2, which I've mentioned before, really is just the median. Quartile 2 is the median, is just percentile 50. Quartile 3 is percentile 75. So for example 8, looking back at the chocolate chips, what is the value of P18? Okay, so we've got to first look at this flow chart here. Sort the data, we know it's already sorted. Compute L, which is K over 100 times N. So L, oops, I'm still in highlighter. L is K, which is the percentile, 18, over 100. And then I times it by N, which was how many data values I have, which was 40. If you run that, you'll get 7.2. Okay, so now let's look back to our flow chart. What does it say? Is L a whole number? Okay, for this one, no, it was not. So we're going this way. Change L by rounding it up. Always round up. Don't round to the nearest, round up. So I'm going to round this up to 8. What L is giving me, L is the location of percentile 18. It is not the answer to the problem yet, but it's the location of it. So it's basically saying, go to the 8th value in your data set. It's the location of it. So I'm going to go, and if I look at my flow chart, the value of PK is the Lth value counting from the lowest. So if I go back to my chocolate chip data, I'm going to count to the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. My answer there is 22. So P18 is 22. Oops. So it's basically saying that 18% of the data lies below that number, or at least 18% of the data. You'll notice with percentiles, there's a little ambiguity, because if I don't have 100 data values, the percentiles are going to be kind of off. For number 9, what is the value of Q1? Well, for Q1, I use the fact again that Q1 is just percentile 25. So think of it as percentile 25 instead, and I can run the same formula. L is the percentile, which is 25 over 100, multiplied by 40. That will give me 10. Now remember, that's not the answer to the problem. Let's go back to our flow chart. Is L a whole number? So the value of the kth percentile is midway between the Lth value and the next value. Find pK by adding the Lth value and the next value and dividing by 2. So basically, I'm going to average it. So what does this mean? We found L to be 10 for this problem. So since I got a whole number, I'm going to go between the 10th and the 11th value. So I'm going to go between the 10th and the 11th value. So if I go back to my data, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the 10th value. Here's the 11th value. I'm going to average those two numbers. So between 22 and 23. So between 22 and 23 would be 22.5. And that is the value of P25. But again, percentile 25 can also be called quartile 1. Off of the quartiles, we get to what's called the 5-number summary. It's basically just the minimum value, the first quartile, the second quartile, which is the median, the third quartile, and the maximum value. And you can see what we do is a box plot or a box and whisker plot that marks each one of these, and notice in between quartile 1 and quartile 3, we put a little box around that data. So for number 10, make a box plot of the chocolate chip data. So I need the minimum value, which if you look back to the data, the lowest value, lowest value was 19. I need quartile 1. We just calculated that on the previous page. That was 22.5. We need quartile 2, which is the median. So let's go back to the data. There are 40 values. So remember, to get the median is going to be between the 20th value and the 21st value. Well, fortunately, they're both the number 24. So what's in the middle of 24 and 24? 24. So my second quartile, the median is 24. I have not figured out the third quartile yet. So I'm going to have to calculate that using the same formula that I did for all the other percentiles. Remember, quartile 3 is percentile 75. So L is 75 over 100 times 40. Calculate that out, you're going to get 30. 30 is a whole number. So that means I'm going to go between the 30th and the 31st value. Back to my data. The 30th value is the number 26. The 31st value is also the number 26. So the average of 26 and 26 is 26. It's going to be the number 26. And finally, the maximum value, if you look back at the data, the biggest number was 30. Now I have my 5-number summary. Also, again, notice 5-number summary and percentiles, these have nothing to do with the mean. The median comes up Median comes up in this, but not the mean. The mean is used for z-scores and standard deviation, not for this. So to make a quick box plot of this, my minimum value is 19, 22.5 for the quartile 1, 24 for the median, 26. Try that again. And then my max was 30. And that does it for Unit 1.